So, hey everyone, and welcome to Sweet Streams Are Made of These, applying data and metrics-driven development to Apache Flink. As Costa said, my name is Kato Schur, and I'm Bavarica's developer advocate for the US region, and based in Portland, Oregon. And I first got started with Flink in 2017 when I was a software engineer at a large data analytics company. My team built my company's first processing data pipeline. I got involved in the Flink community when I spoke at Flink Forward Berlin in 2018 with my teammate at the time, Nick, in this photo. And I spoke there again last fall. And by that point, I'd gotten completely hooked on this awesome Flink community. And then I joined Bavarica this past summer. As a quick related side note, obviously this time around, this conference is a little bit different. The little things like meeting new people before the keynote at the coffee station, being all jet lagged and delirious, seeing who can get the most Flink stickers, or bonding over trips to Berlin's local bars, can't really happen this year, but I've seen what this community can do when we're together, and it is impressive. So I really hope I get to see you all in the virtual lounge and at the virtual Flink Fest, which is going to be awesome. Totally biased because I'm helping host it, but they've done a really great job with it. So this is my shameless challenge to have you all come find me there and tell me your weirdest use cases, because I really miss that. So firstly, I'm going to go into a couple things before we start. So some overview of some basic principles. Next, where to get started. The best data-driven principles all rely on really good metrics and observability. So how do you create a healthy, sustainable metric cycle that's specific to your Flink application? And I jokingly, but also seriously, like to think of this as metrics-driven metrics. And lastly, a powerful, fast, and stateful stream processing engine like Flink has additional challenges in how it impacts the surrounding ecosystem that are kind of just unavoidable. And this part can get a little extra messy as it includes the parts where the technical and the human problems go most hand in hand. I'm going to keep this part fairly short, but I think it's important to end with thinking about using metrics as a shared language to minimize some of those challenges. So this talk is about applying data-driven concepts to Flink. Although I'll be talking a lot about metrics, this is not going to be a step-by-step getting started tutorial because there's already a lot of those and they're really great. So I'll have some resources linked at the end. Secondly, I think it's important for systems to be provider agnostic when it comes to metrics, because if the product that logs, tracks, analyzes, or alerts on your data goes down, it would be really nice to have a backup system. Maybe you have a JSON API that you can query that's just part of your system. So if the worst happens, you have redundancy in your monitoring or logging as well. For this reason, I'm going to try to keep myself provider agnostic for this talk also. So you're going to see metrics from various different monitoring and alerting providers. And although many developers just use the dashboard UI that comes with Flink, I do recommend pairing it with your other observability provider too. So Flink already has a REST API integration, which makes being provider agnostic even easier for Flink. And I've included some examples from the current 1.11 release here for the main available default categories, like requesting metrics for a specific entity and aggregating metrics by type, either for all entities or for a subset. Additionally, Flink also has reporters for some popular external observability providers like Datadog, Prometheus, so that just makes it super easy. As for the basic terms, if you Google the title of my talk, maybe not the pun version, but the subtitle, you probably notice there's a lot of different terms, a lot of different interpretations and opinions on each of those terms. So if you look for data-driven development, most of the information you're going to find is actually more about data-driven design and business metrics. And there's a big overlap between those two, as essentially the main focus there is to use data to drive the design of a product that customers actually want to buy and use. And normally I'd go into each of these, but in the interest of time, I'm going to skip ahead to the fun stuff. So I'll have links to this at the end as well. So this brings us to metrics-driven metrics. What do you measure to know what to start measuring? I know, right? So first, though, you have to start somewhere. On that most basic level, of course, the best start is going to be keeping it simple with a proof of concept or a playground application, starting with that small cycle and growing it with the growth of your application's development. But once you have that, Flink and other stream processing frameworks have key components to measure that are usually listed in their documentation, and Flink is really great at this as well. However, within this, it's kind of easy to get lulled into just measuring that list, measuring what's recommended, which is where good data-driven development practices come in, because that's what's going to give you that leg up for being able to be flexible when your Flink app inevitably gets complicated or maybe just a little bit weird. So I love this dashboard because it's a great example of labeling exactly what's important to this team for their application. In the left column, you have some of the essentials related to the Flink application status. So for any of you that are new to Flink out there, all of these metrics, along with others, are also available on the UI that comes with Flink out of the box. And again, for those of you starting out, quick preview of what those look like. The one on top is the basic one that comes with Flink, and below is the Viverica platform. I picked the free community edition here. And as you can see, both of these have everything we saw on the team's dashboard on the previous slide, plus more as well. It's really great for deployments as well. So secondly on here, another thing I really like about this dashboard is you can see several different complementary pieces of one particular metric all in one place together. In this case, they have fit for checkpointing. So failed checkpoints as a single number is useful, but combining this with the last checkpoint completion over the span of at least several hours is much more impactful. And I want to really emphasize the value in keeping an eye out for opportunities to tightly couple together your granular and your bird's eye view metrics like this. I'll have more examples of that later too. The metrics on the right here, resource utilization and throughput, are very standard, so I won't really be going into those much, but it's worth a shout out to not forget to keep those in a place where you see them pretty regularly. And in terms of getting these set up, as I mentioned, Flink has reporters that allow internal metrics to be exposed externally, and one's already built for specific popular providers. So all of this is very straightforward, mostly through a YAML file that comes out of the box with Flink. You can also configure multiple reporters, and each job and each task manager gets instantiated with these reporters when they're started. So very, very straightforward. And beyond the specific components like these, for getting started with monitoring your Flink application, when it comes to what else specifically for your application to start with, what metrics are actually going to be valuable to you, I found that having one standard answer to that is completely ineffective. So at least for something as complex as Flink. So instead, I found that I was much more successful when I framed this as a process, an ongoing iterative practice of knowing your normal. This is something that one of my old teammates fought so hard to have become a daily routine for our whole team, and it really paid off. So I've personally extended that practice for myself by finding ways of keeping it super simple, focusing on what metrics are meaningful, staying iterative, and keeping them accessible. And as a reminder, none of this is mandatory. You can build a great Flink application without applying any of these tactics or philosophies. But when my engineering team started being more intentional about this, we saw really measurable results, both with our business metrics, so velocity, things like that, and also our comfort levels during incidents, or on the quantitative side, our incident response time, and having much less frustration over cross-team communications, which I'll get into later. So for our first point, starting with some good basic dashboard hygiene goes a really long way to enable a cycle that will help keep your metrics meaningful. So firstly, your dashboard should reflect the values and development priorities of the application that you're monitoring specifically. This may sound kind of obvious or sort of generic, so I want to get into some examples of why this is particularly important with Flink. So on my very first Flink engineering team, this was the top of our main dashboard. And I like this example because it was so carefully curated to really have those metrics that are actually most important to us engineers and that are most driving the development process actually right on top. There were more metrics below. This is actually only about half the dashboard, but we were very selective with what went on top. But we were also very flexible. So if the top engineering priorities changed, so did the dashboard. So this became a normal habit. Whenever it was time to add a new major Flink feature to the sprint or roadmap, we evaluated whether we would need to adjust our dashboard to reflect that current priority. So this is going to change constantly as you go through the development process. This dashboard is a sample from early in that development process. So sure, it's always good to have items that are highest risk on top, but it's also important to have items that contain the most uncertainty for that period of time, or that would need to be adjusted the most frequently, which of course is a big part of knowing that normal. So for us at this stage, our Kafka consumption was extremely important because we're joining many different Kafka topics from various unrelated upstream teams and products. This metric had a lot of uncertainty for us and was something we knew that we had to get really familiar with fast. Even more important than that, though, at this stage was watermarks. Due to the nature of watermarks being so essential to event time operators, late record handling, etc., and the fact that our watermark configuration had to start off as an estimated guess based on virtually no information about our incoming data, Keeping this front and center was integral to being able to build a robust and efficient Flink system, at least until we were confident that our configuration had been sufficiently iterated on and sufficiently attuned to the behavior of our incoming data. So again, starting with what's uncertain, or is based on estimations, or based on an insufficient data pool, these are really great places to start for your metrics-driven cycle. Next, each of our incoming data streams had its own lag chart. By taking some initial measurements of data flow and looking at the structure of the output, we're able to determine that some of our upstream teams aggregated and transformed their data very differently than what we expected, and that it differed by team, which it wasn't supposed to. So this information almost automatically redefined responsibility for all the different integration points in a way that was now instead based on the behavior of the software itself and on the data flow. Throughput and checkpoint size were our next priority. Throughput should be a fairly obvious one. You want to have a good handle on that. And it's another example, though, of finding this opportunity to have a big picture and a granular version of the same metric side by side. So it's hard to see here, but there's a full picture, and then you can click in to see individual throughputs for a particular incoming stream or for groups of them. We also increased our observability into the pipeline by tracking our throughputs at each reduced function throughout the entire system of applications. We had multiple Flink apps. And then, of course, we have checkpoints as well, also very important for any Flink application. But this dashboard has a very unusual way of tracking checkpoints, which brings us to keeping the process iterative. So it's much more common in Flink to track the number of checkpoints like we saw on an earlier dashboard. However, for our team here, at this point in the application's development, due to the incredibly complex legacy system we needed to integrate with, we were under certain restrictions for how we wrote data to our sinks, and some sinks still needed to consume on a once daily cadence. For this scenario, our checkpoint size actually followed a predictable pattern of steady growth and a single once daily drop, always the same size. In this case, an abnormal drop or spike could mean that we were losing state, or in one case, there was a mismatch in how incoming data from different sources were timestamping their records. Although this is a weird edge case, it illustrates how instead of being stuck on just textbook metrics, it was so much more effective for us to stay flexible. It was important to allow the data we were receiving about our system, along with any other information we had on our weird and unique situation, to guide modifications to our metrics, even if it meant monitoring in non-traditional ways. Okay, so you have a dashboard that has meaningful prioritized metrics and supports iteration and flexibility, right? Yeah, looks good, check. But they have to be something that's easy to use, particularly if you get paged at 3 in the morning and you have to make sense of all these pretty lines and colors. So there's a lot of different great techniques about that, but honestly, I found that it's so much easier to just think about scale, because having the right things in the right order is great, but prioritizing a list of 1,000 items is still 1,000 items. And that brings us to accessibility and sort of that actual practice part of the metrics-driven development cycle. And there's also great resources on this, but there's a couple favorite quotes of mine. One is the Harvard Business Review saying, "It is simple enough to describe how to inject data into a decision-making process. It is far harder to make this normal, even automatic for employees, a shift in mindset that presents a daunting challenge." Or more simply, Tech Beacon article that reminds us, you can measure almost anything, but you cannot pay attention to everything, which I both love and hate because I just want to measure everything. I feel like I need this like ingrained on my desk. So my favorite quote on this, though, is actually from another engineer I was talking to recently who said, "Any situation where people can create their own dashboards without structure quickly starts to look like the cockpit of a 747 airplane." And I love this quote because it just gives you a great image of just what an anti-pattern this is. So unfortunately, we've probably all seen dashboards that look like this at one job or another. So this is my chance to just say, nope, 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 nope. This is your reminder. So with that PSA, we can now move on to this last section, which is metrics as a shared language. So there's another Harvard Business Review article that mentions the biggest obstacles in creating data-based businesses are not technical, they are cultural. More specifically, I like to think of this as even the best data-driven development fails easily when it's only built for yourself. So first, this is knowing how to use your metrics as a shared language to enable that smoother communication. And usually, particularly as an individual contributor, you likely aren't really having to think much about this. And most companies, especially larger ones, are already going to have processes in place for cross-team and cross-organizational communication. However, when building and integrating a new or larger scale Flink application, particularly if you're an early adopter at your company, I found that these built-in processes were not enough. And as engineers, we had to do more here to avoid longer-term issues, friction, and some of those people-related slowdowns in the development process. On this previous engineering team I was on, we found that people from all over the company suddenly needed a lot more information. Explaining the same Flink or general stream processing concepts, re-explaining our Flink-specific alerts, and being included in incident resolutions that seemed kind of far from our domain all suddenly became part of our development process. And some groups, like other engineering teams, they needed the same granularity as us, but maybe filtered differently. Other groups needed to be able to pivot between summaries and depth, and still other groups needed full abstraction. So this can get really frustrating for everyone involved and can really slow things down. So I started using this diagram as a starting point for automating cross-team communication for any new or more complicated Flink applications. Here, the groups are clearly delineated, where the ones at the top need the most in-depth technical coverage. And as you get further down, the information and the way of sharing them become more and more abstracted. And due to time, I'm just going to go through two sections here. So first, your fellow engineering teams. We knew that if everyone was looking at the same initial metrics, no one would get the information that was useful to them, even the other engineers. So there had to be some type of filtering or abstraction, but it didn't need to be complicated. Most of this actually just ended up being using a couple more data-driven concepts, including just keeping our alerts in small modular units and using the language and tools of our intended audiences. In the end, it was a super simple solution of just relabeling alerts and monitoring, putting a tag on them with the team that it was going to impact, and using Slack integrations for PagerDuty, Jenkins, etc., and just routing the alerts that pertain to a specific team to a Slack channel that just had that team in it. Super simple. We tried things that were much more complicated and way more fun to program, way less fun to use. So this ridiculously simple method scaled better than anything that we tried and enabled us to really automate this. So as a quick example of this, so this is a slice from that earlier dashboard of our Kafka lags. Initially, we were alerting on any spike over a certain threshold. This threshold had made sense to us in the context of our data pipeline and was based on the behavior of the majority of the streams that we were consuming. But it turns out the spike at 9:10 to 9:15 a.m. is actually normal and expected for all three of these apps based on how and when they all receive their data through the day. So again, we had some batch and some streaming. This would have been abnormal for all the other ones. So there's some gotchas here. So when working around a daily spike or drop that's nice and predictable like this, there are great things you can do to compensate. And this was one thing that was very helpful for us. But it turns out that if you have different teams all doing separate things like this, you have to be aware of whether those upstream teams are going to decide to change their data collection or publishing schedule, or worse, turns out that autonomous teams don't always have to base their event time processing in the same time zone. So you could have one team using, say, UTC, and another using a time zone that maybe handles daylight savings time completely differently, like PST. So this is so much more important while we're all working from home now too. Using metrics like this can greatly decrease the amount of miscommunications that are so prevalent in companies that are recently switching to working from home and are still adjusting. So overall, this is an example where enabling metrics to continuously guide how you're measuring and alerting on your data and using that to communicate is so important here. So lastly, I know we're running out of time. So for one of our more abstracted groups, normally this is where things have to get a little more manual, but I believe this can be automated. So the best trick I found for this is really using the language and tools of your intended audience. So what we did here to automate this was we just created a blog post with language catered to each of these different groups. This actually included the customers as well. And we just embedded a few charts that were automatically updated on a regular cadence. Boom, done. It was awesome. So automate all the things. So with that, we've covered using metrics to drive our Flink development process by knowing your normal, doing this by keeping your metrics meaningful, iterative, and accessible. We've also covered metrics to minimize some of those human challenges that come with such a powerful stateful stream processing engine like Flink. Specifically, that's automating, filtering, abstracting metrics in a way that makes it work for these different groups, keeping it simple with those small modular units and using the tools of your intended audience. So with that, for real, I would love to hear any of your questions or just geek out about Flink. I know I've probably run through my Q&A session, so feel free to reach out to me with other questions afterwards. And thank you all so much. Huge thanks to the Flink Forward team. A particular shout out to the marketing team, my fellow DevRel coworkers, and our SA team and to Costas. Thanks so much. And that's it.